Bismillah Rahman Rahim. Once again, welcome to my new lecture. I'm Zahur Islam and you are watching my lecture on my YouTube channel Zahur Islam Official. So let's take a start from molarity. Today the topic which I'm going to explain, that is molarity. So molarity can be defined as simple, it is the concentration term for the solutions. As usually, this term is used for solutions for the concentration, the quantity or the amount. So it is the number of the moles of solute which is dissolved in 1 liter of a solutions. So it means that and how much amount of solute you are going to dissolve in 1 liter of solution. So if you want to calculate the molarity of solution, simple, we will divide the moles of solute by volume of the solution. Let's see here. Molarity can be represented by a capital letter M, that is equal to the number of moles of a solute divided by liter of a solution. So this is very simple formula, and with the help of this formula you can easily find out, can easily determine the different problems by using this formula. So you must know about the basic vocabulary to know the Avogadro's constant. Avogadro's number or Avogadro's constant. This is actually the number of the objects in a mole, that is 6.023 multiplied by 10 raised to power 23. So this is Avogadro constant. You should remember this value. How we will define the mole? So mole is the amount of a substance that contains 6.02 multiplied by 10 raised to power 23 particles. The amount or the quantity of a substance that contains 6.023 multiplied by 10 raised to power 23 particles, atoms or ions. Mole of any pure substance has a mass in grams exactly equal to that substance atomic or molecular mass. And in other words, if we represent any pure substance which has a mass in grams, that is exactly equal to the substance atom or molecular mass. What is molarity? So molarity is simple, the unit, it is a unit of concentration which is equal to the number of moles of solute in 1 liter of solution. So I mean that you must will have 1 liter, you will have to dissolve that specific amount or the number of the moles of a solute which is given. So it would be dissolved in 1 liter of a solutions. And in other words, a mole of any pure substance has a mass in grams exactly equal to the substance's atomic or molecular mass. So the mass of 1 mole of a substance. So from this example, it will be clear to all of my students. This is the molecular mass of. First of all, you should know about, for example, carbon dioxide is a gas and its molecular mass is 48 gram per mole. So the molecular mass of carbon dioxide, so here is 1 carbon and 2 oxygen. So the atomic mass of the carbon is 12 and the oxygen atomic mass is 16. So in this case the oxygen is 2, so then it will be multiplied by 2, so it becomes 16 multiplied by 2, so it becomes 48 gram per moles. Now it means that 1 mole of every substance contains 6.023 multiplied by 10 raised to power 23 particles. So this is Avogadro constant, 6.02 multiplied by 10 raised to power 23 molecules of carbon dioxide, which is equal to 48 gram. Now let's come here. Okay, this is periodic table. The atomic mass of carbon is 12. So how you will find out the molecular mass? To combine all these atomic mass, so it becomes the molecular mass of that particular compound. So the atomic mass of carbon is 12, the atomic mass of boron is 0.8, the atomic mass of nitrogen is 14, and the this is the atomic mass of the oxygen is 15, while the atomic mass of fluorine is 18. So you must know about the atomic mass of that particular atom. Now come toward the molarity dilutions. For example, 1 mole solution of NaCl is equal to 58 gram NaCl, so it must be dissolved in 1 liter of water. So this is clear that if you have 1 ml solution of NaCl, so it must contain 58 gram NaCl, and it will be dissolved in 1 liter of H2O or water. So sodium is 23, chlorine is 35, so it becomes 58 gram. Look at here, this is 1 milli mole. So 1 millimole means this is 1 ratio 1000 dilution of 1 mole or 10 raised to the power minus 3. So you should know about this basic calculation. So 1 millimole mean 1 ratio 1000 dilutions of 1 mole or 10 raised to power minus 3. 1 micromole mean this is 1 ratio 1000 dilution of 1 millimole or 1 ratio. Yeah, I mean that this is micro mean 10 raised to the power minus 6. So it mean, for example, if you have two solution, one is 1 millimole and the second one is 1 micromole. So look at this one is more diluted. So this is mean the dilution is 1 ratio. So 10 raised to the power minus 6, and this one is 10 raised to the power minus 3. So this one is more diluted because we are going to decrease the concentration. Now this is 1 nanometer, so 1 nanometer mean, and for example this is 1 nano means small, very small. So it mean that 1 ratio 1000 dilution of 1 micrometer or 1 ratio mean 10 raised to the power minus 9. So I mean this is more diluted than 1 micrometer. For example, if you have two solution, one in micrometer, one is in nanometer, so the nanometer is more and more dilute. So it means we are going to decrease its concentration more and more. So 1 fecometer mean the dilution in 10 raised to the power minus 1. Now look at this example. So what is the micro, or you can say this is micromoles concentration of 1 ratio 10,000 dilution of a solution containing 18 gram of NaCl per liter. So how you will find out the molarity? This is very simple calculation. So 1 mole of NaCl is equal to 58 gram per liter. Then we will do the cross multiplications. So it become 1.5 mole. So it means that 1 mole of NaCl has molarity 1.5 moles. So it means that 1 ratio 10,000 dilution of 1.5 mole is equal to 150 micrometer. So this is very simple calculation. So please do practice on it. So inshallah, in my next lecture we will talk about the different problems related to molarity, and then inshallah our next topic will be normality. Thank you.